Hello and welcome to Geometry, the Pythagorean Theorem and its converse. In this video we are going to solve problems using the Pythagorean Theorem and its converse. That means we're going to be using the Pythagorean Theorem to find the side length of right triangles, determine if three side lengths form a triangle, and determine if a triangle is right, obtuse, or acute. Here are some of the standards that we are going to be covering in this video. These are from the Florida's Best Standards for Mathematics. So let's go ahead and get started. So the Pythagorean Theorem is c squared equals a squared plus b squared. And c, this is the most important part. C is always going to be the longest side of your triangle. So for a right triangle, it's going to be the side across from the largest angle, which is that 90-degree angle. And that's called the hypotenuse. So that is always going to be C. And then from there, we have the two legs of our triangle, and those are going to be A and B. And it doesn't matter which one you set as A or B, it's going to work out the same. But C always needs to be across from that 90-degree angle. So let's go ahead and get started with this first one. So with this first one, I have X, 9, and 15, and I'm always going to put this across and go ahead and label this as my C. This just helps me remind myself of how I'm going to put it into this formula. So now I have a squared plus b squared equals c squared, and I know 9 is going to be my A. And then if you would like to replace b with x, you can. It doesn't really matter. You could leave it as b if you want. And then c is going to be 15. So now I have 9 squared plus x squared equals 15 squared. That's going to give me 81. This is going to give me 225. If you don't remember how to put it in your calculator, you can just use this squared button, and so 15 squared, or you can use your y to the x button. It really doesn't matter. So if I did 15 y to the x 2, it's still going to give me 225. And then from here, to get x squared by itself, I'm going to subtract on both sides. Now I have x squared is equal to 144. And then from here, you're always going to end these with the same process. So to get rid of that square, we have to take the square root. And that gets rid of this part here. And now I'm just left with x is the square root of 144, and I know that is going to be 12. To use your calculator, you're going to do 144 and then hit this button here, and that gives us 12. All right, now let's do this other one. So I have a squared plus b squared equals c squared. I always want to label my c just to help remind myself, and that means we're solving for c this time. So now I have 45 squared plus 24 squared equals x squared. 45 squared is 2025 plus 576 equals x squared. When I add these two together, I get 2601 equals x squared. And then from here, I'm going to take that square root. And for this one, it's going to be 51. All right, let's try some more. Okay, so the first thing I do is label my C. If it helps you, put that on your reference sheet right when you get it, just to kind of help remind yourself. And here we go. We've got a squared plus b squared equals c squared. And then I have 4 over 9 squared, and I like to put my fractions in parentheses, plus x squared equals 5 over 9 squared. Now, I could do this by hand, but I'd rather let the calculator do all the work for me. So I'm actually going to go ahead and subtract this. So we saw how we would subtract every time we are looking for b. And so x squared is going to be 5 over 9 squared minus 4 over 9 squared. And then what we'll do is we'll go ahead and throw this in our calculator. So I have parentheses 5 divided by 9 close parentheses squared. Don't worry about those numbers, they're going to look weird. Minus parentheses 4 divided by 9 close parentheses squared. Then I'm going to hit equals. So that's what x squared equals, and then don't forget that we do our square root at the end. And so now I'm going to take this number and square root it, and now I know what that is as a fraction, but I'm going to have my calculator go ahead and transform it for me, and so now I have x is equal to 1/3. Okay, let's do the next one. We've got c. And if you want, you can try to do that with the other ones as well, if that's something that you're into. I like using my calculator for everything. The more my calculator can do, and I can save steps and save from writing things down, that's what I tend to do. All right, and then from here, we have 16 squared, which gives us 256 plus 1089 equals c squared. And then from here we get 1345 equals c squared. Now, there are some problems where they're going to ask you to simplify the radical. And so you might want to go back and watch my video on simplifying radicals. For these in particular that I have in this video, they don't simplify out. Either they simplify out to a whole number, or we're just going to use a decimal version, a rounded version. So for this one, we have c is equal to 36.7. Okay, and then let's go ahead and do this last one. A squared plus b squared equals c squared. And notice that I'm always writing out my formulas. I rarely will just put my numbers out there. Especially when I'm taking a test, I like to write them out. That way I can always go back and check my work. It makes it a little bit easier. Oh no, I put this instead of this. It just makes it easier for spot correction. All right, so now from here, and notice that I'm always labeling my C. I still did do this on my papers today. So I'm always going to put that little arrow, mark C, and that way it's just help training my brain, especially when I'm taking a test where my anxiety and my brain is kind of moving faster than my hands sometimes. All right, so now we've got 11 squared plus x squared, or you could leave that as b squared, it doesn't matter. And 11 squared is going to be 121 plus x squared equals 784. Then we subtract. Notice that with these problems, you're always doing the same thing. It's either going to look like this one, where you're solving for b squared, or this one where you're solving for c. So it's always going to look one or two ways. It's never going to be different. And so we've got x squared is equal to 663, and this one does not simplify either when I take my square root. So sometimes they'll ask you for the square root or the simplified radical, or they'll ask you to round, like in our directions up here at the top. So we've got x equals 225.7 for this one. So now let's go ahead and move into how we can use the Pythagorean theorem to classify our triangles as either right, acute, or obtuse. But first, we need to talk about the triangle side length rule. So the triangle side length rule, to even figure out if three lengths can even give us a triangle, the lengths of our two smaller sides have to be greater than the longest side. So this is always our longest side. And when we're thinking about this, let's think if we had a string that is 10 inches long. If I have another string that is 2 inches and another string that is 4 inches, they're never going to meet up to create a triangle. They're just too far away. And so 2 plus 4 is only 6. It's never going to reach because that 10 is just too long. So then if we have a string that is 10 inches long, and let's say we have two strings that are 5 and 5, well, if we have 5 and 5, they're just going to collapse down. They'll meet each other, but they're just going to collapse down onto the 10. And so even if they're equal, it doesn't work out. And so you have to have it to where the two smaller sides have to add up to be longer than that greater side. So let's take a look at this first one. So here's our longest side here. And so I'm going to say 5.6 plus 4.0, and we want to see if it's greater than 10.6. I know this is going to be 9.6, and so that is not going to be greater than 10.6, and so this is not even a triangle. And so I would just stop there. I wouldn't even use the Pythagorean theorem to classify it because it's not even a triangle. All right, let's take a look at the next one. So the next one, 17, is our longest side, and so we have 9 plus 12. That's obviously going to be greater than 17, and so this is going to be a triangle. So yes, it's a triangle. And then from here, now we can use our Pythagorean theorem. So we're going to take 9 squared plus 12 squared, and we want to compare it to 17 squared. And so with this one, I'm just going to 9 squared plus 12 squared, and that gives me 225. And then I'm just going to do 17 squared, and that gives me 289. And that means that c squared, because remember I always want to look at what's on this side, is larger than my sum, and so that makes this one obtuse because c squared is larger than the sum. All right, let's try another one. So with this next one, this is our largest. So I have 9.6 plus 18. That's obviously going to be larger than 20. And so this gives me 27.6 is greater than 20. So that's going to be yes, it's a triangle. And now we can talk about what type of triangle. So now I'm going to do 9.6 squared plus 18 squared, and then we're comparing it to 20 squared. So go ahead and just put that into your calculator. So we've got 9.6 squared plus 18 squared, and that gives me 416.16. And then from here, you could probably do this in your head, but we've got 20 squared, and that's going to give me 400. Now when we look at this, I can see that c squared is less than my sum, and so that's going to be acute. Okay, all right, so now let's try one more. So let's say they give us coordinates. The first question, is it a triangle? Of course it's a triangle. Why? Because I have 3 points on a coordinate plane and I'm connecting them. So I can create a triangle on a coordinate plane as long as I have 3 points. So my first question is already answered. So now it comes down to the triangle side lengths. So this means that we want to use our distance formula. So with our distance formula, we have x and y, and I'm just going to go ahead and go straight through it. First, we want to, let's kind of highlight these. And so we've got -7 minus -2 squared plus -3 minus -5 squared. And so that's going to give me -5 squared plus 2 squared. And that's going to give me the square root of 25 plus 4, which gives me the square root of 29. And then I'm just going to do that for the next two. So now I have all of my lengths, and so we can see that this xy is going to be our largest length. And so now from here, I'll go ahead and put this in another color. So now I'm going to have 13 squared, which is just 13, plus the square root of 20 squared, which is now just 20. And then I'm going to compare that to 29 squared. And so this is obviously going to be larger. 13 plus 20 is going to be more than 29. And so with these, just make sure that you recognize that we are squaring radicals, and so it's just going to be what's underneath the radical, or the radicand. And so 13 plus 20 is going to be more than 29 in this instance. And so that makes c squared smaller, and so this is going to be an acute triangle. All right, and that is the last for our video.